Hello everyone. My presentation is about Melbourne, Australia temperature analysis using Sarima modeling. The dataset contains monthly minimum temperature observation from 1981 to 1990. The main purpose is to understand the pattern in the temperature series, identify seasonality, select a suitable Sarima model, and produce a short-term forecast. This slide shows the original time series plot, ACF plot, and PSCF plot. The time series plot shows a clear movement over time with repeated seasonal fluctuations. The temperature pattern appears to repeat annually. The ACF plot shows strong autocorrelation and a slow decline, which suggests that the series is not stationary. The PSCF plot also shows significant early lags. These results indicate that seasonal modeling is required. For model specification, seasonal differencing was applied at lag 12 because data is monthly and has a yearly seasonal pattern. After differencing, the seasonal pattern was reduced and the series became more stable. The ACF and PSCF plots of the difference series were then used to identify possible Sarima orders. This helped shortlist suitable candidate models for further estimation. This slide shows the seasonal ARIMA modeling stage. A SARIMA model was fitted and the residuals were checked using the residual plots, ACF and PACF. The purpose of this step was to check whether the model removed the remaining seasonal structure from the data. The residual appears more stable than the original series, but some autocorrelation still remained, so further model comparison was needed. In the model estimation stage, multiple Sarima models were compared. The residual ACF and PACF plots were used to check whether the residuals were close to white noise. The BIC table was also used to compare model performance while considering model complexity. Based on the residual behavior and BIC results, then Sarima was selected as the final model. This slide presents diagnostic checking for the final Sarima model. The residual time series fluctuates around zero, which is a good sign. The histogram suggests approximate normality, and the QQ plot follows the straight line reasonably well. The residual ACF shows that the most spikes are within the confidence limits. Overall, the diagnostic results suggest that the final model is acceptable for forecasting. This slide shows the forecast generated using the final Serima model. The forecast suggests that the temperature series will continue to follow a seasonal pattern in future periods. The predicted values remain relatively stable with regular fluctuations, which is consistent with the historical behavior of the data. This indicates that the Serima model is able to capture the seasonal structure effectively. In conclusion, the Melbourne minimum temperature series showed strong seasonality and a non stationary behavior. Seasonal differencing and Serima modeling helped improve the series and identify suitable model parameters. After comparing different models using residuals, analysis, and BIC values, Serima was selected as the final model. Overall, the model produced reasonable short term forecast and performed adequately for the temperature analysis.